There was a moment that really stuck with me. I was sitting in a classroom and it felt unusually more stuffy. Not hot, not noisy, just stuffy. It was harder to concentrate, my head felt slightly tight, and everything just felt slower than usual. I remember stepping outside and feeling instantly better. That contrast made me very curious. Living in Delhi, we always talk about outdoor pollution, but indoor air quality is something we completely ignore, even though we spend most of our time indoors. That's when I started to wonder that what I was feeling may be related to what was inside the room and not just tiredness and boredom. This simple question is what eventually led to this project. Once I started researching carbon dioxide levels, I learned how carbon dioxide levels can build up in enclosed spaces, especially in classrooms with students and poor ventilation. What surprised me the most was that high CO2 levels don't just affect comfort, they affect focus, decision making, and learning performance. That made this problem feel very real and personal. It wasn't just some abstract environmental issue, it was affecting me in my regular life. And not just me, many students. I didn't want to build something expensive or complicated. I wanted to build something simple, practical, and easy to understand. A system that tells you when the air quality in an enclosed space is no longer ideal and ventilation is required. That idea became the S.V.O.E, the Smart Ventilation Operating Evaluator. The goal with the S.V.O.E was to create a compact embedded system that could continuously monitor indoor environmental conditions and present the data in a clear visual way. Before building the physical hardware, I planned the system layout and connections. This helped me understand how each component would fit together and communicate. This planning phase made the actual implementation much cleaner and easier. Now let's move on to the actual components used in the project. The main controller of the system is the ESP32 microcontroller. This acts as the brain of the S.V.O.E. It reads sensor data, processes it, controls the display and the LED indicators, and also connects it to the internet using Wi-Fi. For air quality measurement, I use the MHZ19C. It is a non-dispersive infrared or NDIR CO2 sensor. Basically, it shines infrared light through the air, and since CO2 absorbs infrared at specific wavelengths, the sensor can accurately determine how much CO2 is present. This is the key parameter that determines whether ventilation is needed. To measure temperature and humidity, I use a DHT22 sensor. These values help provide additional context about the indoor environment and make the system more complete. And 0.96-inch OLED display is used to show real-time values of CO2 concentration, temperature, and humidity. This ensures that the information is always visible and easy to interpret. Finally, LED indicators are used as a simple but effective alert mechanism. They visually indicate whether the air quality is normal or if the CO2 levels have crossed the safe threshold. Software side, the ESP32 is programmed to read data from all sensors at regular intervals. Each parameter, CO2, temperature, and humidity, is processed independently and displayed in real time on the OLED screen. A predefined safe threshold is set for CO2 levels, and once that threshold is crossed, the system activates the alert using the LED indicators. One of the key features of the S.V.O.E is its IoT integration. Using ESP32's built-in Wi-Fi, the system uploads sensor readings to an online spreadsheet. This allows the data to be stored, reviewed, and analyzed over time instead of just being viewed live. I've also uploaded the complete source code for this project to GitHub so anyone interested can explore, modify, or build upon the system themselves. Now I'll move on to the live demonstration of the system. In this clip, you can see the OLED display showing the current CO2 level along with temperature and humidity. As conditions in the room change, the values update in real time. When CO2 levels start to increase due to reduced ventilation, the LED indicators change to clearly show that the air quality is deteriorating. Once fresh air is introduced and CO2 levels drop back into the safe range, the system returns to its normal state. This makes it very easy for anyone in the room to understand what's happening without needing the technical knowledge.
To sum it up, the S.V.O.E is a simple, low-cost, and practical solution for monitoring indoor air quality, especially in environments like classrooms. What started as a personal experience, feeling uncomfortable and stuffy in a classroom, soon turned into a project that integrated embedded systems, IoT, and real-world problem solving. This project helped me learn how small environmental factors can have a big effect on productivity and how technology can be used to make those effects visible and actionable. Thanks for watching.